Hi everyone. So today we'll go at a medium question, which is called product of arrays itself, X itself, which on first look seems very easy, but then we realize it has a bit of, you know, spice, masala in it. Uh, that's what I realized. Let's see if I can help you guys figure it out. So what it says, given an integer array nums, return array answers such that answer I is equal to product of all element of nums except nums of I. What it means is for 1, 2, 3, 4, the output would be for first position except 1, all the other elements have to be multiplied. So 2 into 3 into 4, 24. When it's at 2, 1 into 3 into 4, 12. When it's at 3, 1 into 4, 2 into 4, 8. And when it's at 4, 2 into 3 into 1, 6. Right? Now, I'll just go into an explanation phase and just explain why it has a lot of spice. My first thought at this was, so I'll just write it was code 238. If you have an array 1, 2, 3, 4, right, and if you have the product of all elements, let's say capital P, right? This is the array, and P would be 24. Now, when it says except self, you can just go to that exact position and just divide by that number. So 24 by 1, 24 by 2, 24 by 3, 24 by 4, which gives us the exact result we want. Well, 8, 6. But funnily enough, this should work. This should work. Funnily enough, it does not. Why? Because there is a constraint here that nums belongs to minus 30 to 30 any number. And if you know integers, you also know that there is a very, very nasty little integer which absolutely destroys you during multiplications. What's the working? Yeah, there is this number called zero. What zero does is if you divide p by zero, it will give nothing. Also, if there is a zero, say 1, 2, 3, 4, 0, the p just immediately goes to 0. For this 4, it will give divide by 0 error. And for this one also, it will give divide by 0 error. So if you think that, okay, I'll brute force that whatever is without 0, I'll just put that thing as 0. Whatever, if it has 0 at the first place, any element which is not 0, I'll put it as 0. And then for the element that contains 0, I'll just multiply all the other. What if it is something like 1, 2, 4, 0, 3, 0, 4, 3? So now it has two zeros. So you have to store both their indexes. So in short, it's not very viable to do the product thing. What we can do, what another thing we can do, 1, 2, 3, 4. We can say, okay, we take a regular result. So for I at position 0, I mean index at position 0 and i's value 1, we multiply all other indexes, right? So we get 2 into 3 into 4. For 2, similarly, we get 1 into 3 into 4. For 3, similarly, we get 1 into 2 into 4. And for 4, we get 1 into 2 into 3. And then we just print it out. Obviously, it's 24, 12, 8, and 6. But then again, it has two for loops. It is of and square, not very beneficial. So we go to a different method, which is what if. when I'm on this element, I know the product of all the elements before it and product of all the elements after it. So product of all the elements before it, we put wow, so product of all elements before it, let's call it pre, and product of all elements after it, let's call it post. Okay. So how will the pre-array? Since one has no elements before it, it will just be one. 2 has 1 before it, it will also be 1. 3 has 2 and 1 before it, it will be 6. 4 has 3, 2, 1 before it, it will be, sorry, 3 has only 2 before, 2 and 1 before it, it will be 2, and 4 has 6. It is 3. It is 3. So it in 3 in red, 1, 1, 2, and 6. Similarly for post, 1 has 2, 3, and 4 after it, so it will be 24. 2 has 3 and 4 after it, so it will be 12. 3 has 4 after it, so only 4, and 4 has nothing after it, so it will be 1. Now, if we multiply pre and post, we see that what happens, the essential is, for that particular element, we have everything multiplied before it, everything multiplied after it. So if we multiply these two, we'll get the multiplication of all elements except that particular element, 8, 6. Now question is, how do we populate tree? One option is again O of n square method. You take one and which is yeah, you take one, you say 2 into 3 into 4. You take two, you say 3 into 4. You take three, you say only 4. So this is how we sorry, I was going to post. So how suppose we are at 3, right? We are at 3. I'll change the color. Suppose we are at 3. Now for 2, we know product of all elements before it. So I am talking about only pre at this point. So for 3, product of all elements before it will be this up to this, right? Up to this, which is the product pre of 2. So I let me just write it like this. So if you think pre of x as a function of x, which is product of all element before x, right? So for 1, 2, 3, 4, pre of 1 obviously will initialize it as 1. Pre of 2 will be pre of 1 into element which is 1. Pre of 3 will be pre of 2 into the element which is 2. So we don't have to multiply all the elements every time. Similarly for post, similar thing for post. Now you can do this, but then again, once I tried it, it gave me error called out of bounds, which is basically a constraint error. Now, very interestingly, we'll make it more optimal. How? 1, 2, 3, and we have 4 here, right? So suppose we have results array already defined, right? And we do the pre. Okay, we do the pre. So what happens? First we put 1 here. So we take results array already initialized as 1. Now we do the pre. For 1, it's 1. We multiply 1 by 1. It stays as 1. For 2, it's also 1. So for 2, it's I'll just note along the pre, right? I'll just note along the pre also here and what the results will look like after. So what we're doing is we are at 1, the pre is 1, the result will be 1 into 1, 1. At 2, the pre is also 1, the result will be 1 into 1, 1. At 3, the pre is 2, so the result will be 2. At 4, the pre is 2 into 3, 6, so the result will be 6. Now our pointer is at this point. What if we take the results array and directly do post on it? Since our pointer is already pointing at 4, what if we took the result array? So our current result array, as you remember, it was 1, 1, 2, 6. What if we directly do post on it? So how will post look? Post will say that, yeah, this is one, new results. So we'll just directly multiply post. Instead of doing a pre into post, we'll just run the pre once and we'll run the post once and directly multiply them into results. So we don't have to waste extra space. So this is also beneficial from a space point of view. From a time point of view, it will take the exact same time. I mean, exact same time complexity, not the exact same time. There will still be some more time needed to multiply all the array elements. But so post, it's 1, 6 into 1 is 6. Now I is here. Pointer is here. The post is 4, 4 into 2, 8. Pointer here, 4 into 2, the post is 8. Sorry, 4 into 3, the post is 12. The post value is 12. And 12 into 1, it gets 12. Now the pointer is here. And 12 into 2, it is 24. And the result is 24, which is exactly the result we're looking into. Now, if you're doing this also, it takes an account when there is a zero. As you can see in the test case, it will take into account when there is a zero automatically. Since we are multiplying each singular agent, we are not doing any division or anything like that. So let's just, enough of the talking, let's just get into the code. Let's just look at it once. I already solved it. So as you can see, we have initialized a result array. So n is length of numbers. We've initialized the result array. Our pre has been set to 1 and we have done the prefix sum, prefix multiplication, which is result of I will be equal to pre and pre will be increased to pre will be multiplied with nums of I. So if I just put here print result I comma pre pre at so let's just do at I at I P is at I result is this result and we'll add a similar one here already. Let's just paste it and just put at I result and so if I just run it once, okay. So it says for the first run for the run from left to right at zero result is one and pre is also one. So now the zeroth index will be updated to I'll just add one here. Okay, never mind. At one, the result is again one, and the pre is. I think I should update the result once here also. Okay, so it will be better. Print result. So initially result was 1111. At zero, at zeroth index, result is one, pre is one, and then it has been updated to 1111 itself. At first index, result is 1 and pre is 2. So it is still 1111 because result is still 1. But at second index, now result is 2 because pre into result at that point. Pre into result at that point. Or result is exactly set as pre. For now, its result is exactly set as pre. We don't have to multiply. Since it's 1, we can just set it. So at 2, result is 2, pre is 6. And at 3, result will be 6. And pre will be 24. But now we don't need pre anymore because we have reached the end of array. Now for the right to left, for the reverse one, obviously you have to set the range correctly. It's range n minus 1 comma minus 1, and we are going minus 1 places, so you should take care of this thing. Now at 3, result is 6, result is 6, and post is 4. Now we are multiplying, now we have to multiply. So it is 1126, right? Because we have multiplied. Now 1128, post is already 4, 2 into 4 is 8, and now result will become 1186. Now post is 12 at 1186. If you multiply 12 at the second index, which is 1, it will become 11286. Similarly, at 0, result is 24, post is 24, and we get the actual result as 241286. So as you can see, in a case of 0 also, you can check it out. You can pause the video and check it out. The print statement works like that. So maybe you can do a dry run on pen and paper, or you can add some print statements and look at it better. But for now, this is the solution for this question. And I'll see you in a different video. Before that, let me just submit it and show you that this works. So command enter. And as you can see, this has been submitted. This is the correct solution. So see you in a different video. Goodbye. Have fun. Take care.